Okay, can everyone hear me? Raise your hand if, yeah, cool. This is my first talk, so I'm a little bit nervous. I'm going to actually take a picture for my mom. So if everyone can like wave. Awesome. Yes, all right. All right, cool. So my talk is about authorization, service-oriented authorization. My name is Alan, by the way. You can find me on Twitter and GitHub. I work at a company called the Climate Corporation. I'm a Ruby developer there. I've been there for about a year and a half, working on, we have an insurance product. I work on the back end as well as other parts of our web infrastructure. We have products that help protect farmers from weather disasters and improve their farming operations during the planting and before and after the planting season. It's sort of like, if I'm going to make it like buzzword compliant, it's big data farming. So a little bit of background before I get into my talk. What is authorization? So if you were in this room before, you probably learned about authentication in a service-oriented environment. Today I'm talking about authorization. So authentication is concerned with identity. Authorization is concerned with access. There are different types of authorization, if you've ever implemented it. You could think about role-based access control, attribute-based access control lists, rule-based access control. It can go on and on. I'm not talking about a specific implementation of authorization, but just in general, right? What is service-oriented architecture, right? There's been many, many talks. I think this entire track is on service-oriented architecture. And there's been talks yesterday. I've gone to a few of these talks. Service-oriented architecture is many different solutions to different problems, but it's around the same theme, I guess. Where I'm not talking about a specific implementation of SOA. So I wanted to find a really basic definition of it, and I found this: a loosely coupled architecture designed to meet the business needs of an organization. I found this on the Microsoft Developer Network site, and it also had this really interesting quote, and it started with SOAs are like snowflakes. No two are alike. But I wanted to find a better definition, and actually, when I was watching Brian Morton's talk from Big Ruby last year, Rails, services in Rails, the shit they don't tell you. He says components that scale individually. That's sort of how he defines service-oriented architecture. And I recommend that talk if you want to learn about implementing service-oriented architecture, some services-oriented architecture from someone who has the battle scars of moving over to something like that. But today I'm not focusing on what it is. So why talk about it, right? Why services-oriented architecture? We have to, before we get into authorization, I want to talk a little bit about why we would use SOA. SOA gives us a lot of things, right? Reusability, we can allocate resources as we need them. Loose coupling, we can change out libraries. A code base that scales across teams, and so we get things that are good for both our software and for our software development process. There are a lot of problems also, right, that you have to solve when you have a service-oriented architecture, right? Services speaking to one another, a lot of things become difficult. But hopefully you're here because the benefits of SOA outweigh the problems that you might have, and you've already sort of made that decision. I'm not going to try to sell you on it. So what is service-oriented authorization? Well, if we think about the benefits of services-oriented architecture, it should be sort of parallel to that. Reusability, I want to be able to use the same authorization tools, libraries, code, across multiple services. Loose coupling, my application code is not coupled to my authorization implementation. And then lastly, scalability. So this is like a requirement when you have multiple services, and this is just going to be like a general requirement when we talk about like the framework that I want to use. So let's imagine a typical Rails application, ignoring things like the database and other third-party services. You have Rails, you have your business logic, and then you have some third-party gems that you might use. The important part is your business logic, right? That's like if you have an online product like Basecamp, right? That's the interesting stuff. That's the part that's going to make you money. It's why your customers pay you money. Everything else is just there to help you deliver that product. I think authorization can be thought of as part of your business, whether it's part of the security of your application. For example, like you have employees that only your employees are allowed to administer customer data, like for customer support, or whether it's part of the feature of your application, like in Basecamp you have like admin users in different groups. So what does authorization look like today? I think the most popular authorization library is, I don't know if you can see this, but this is like a snapshot of CanCan's GitHub page. I think it's probably the most popular authorization gem. We use it in production. It works. It's historically been well supported. I think it's still pretty good. But it gives you like a really nice declarative DSL for specifying rules. So then you specify your rules like within your application and this like nice Ruby DSL, and then you can ask questions like, can a user manage this other user's data? Can a user purchase a policy if you're selling insurance? But the question is, does this approach align with what we defined as service-oriented authorization? Right? CanCan is reusable, right, because it's a library. So, the authorization implementation is decoupled from our app. We didn't like bake authorization into our app. But it's not really loosely coupled, right? If you think about it, your authorization rules are embedded in your application code, right? So like the what is it? Yeah, your rules are in your application, and there's some limitations to this approach, which aren't apparent at first, right? And so what? Like, what are those limitations, or why does that matter? Well, I think that if we want to keep the core of our application small and understandable as possible, we want to do that because that's the part that makes us money. The business logic is what's important, and it's the part we want to keep free of bugs. If we do that, we can develop with confidence. Like we won't develop and create bugs. Our business logic is concerned with authorization only as far as we need to make sure to enforce it, but we shouldn't care about how it's implemented, but just that it works. So this is your business logic. This is you enforcing authorization in your code. But the rest is, I think, should be thought of as implementation details, right? Where you define those rules. It doesn't necessarily need to be part of your system. It needs to exist somewhere. And I'll explain why that matters, right? So in a services-oriented architecture, right, you usually start with a monolithic application. And if we've coupled our rules to our application, then it's going to be very difficult to split things into services, right? Especially if all these services are concerned with a user. You have all these user rules in your mono-Rails app, but now they sort of have to be broken out. And that's fine if you're going to use CanCan across these different Ruby or Rails applications. But a services-oriented architecture usually by default means you're going to have like a heterogeneous environment. And this is actually very similar to what we have in production today, where we don't just have the Rails stack. We have other things, either in Java or Clojure or whatever it might be in the future. And there really isn't an easy way to go from CanCan to Clojure, right? So we want to think about a different framework to basically do this. So what are the goals of whatever approach we take? Well, the goals, restating them: reusability, scalability, and loose coupling. So let's go back to our app. Right, we have the same Rails app, but it's very simplified. Your app, when you move it onto different services, might look like this, where you have different JavaScript front ends that are, we deploy them as different modules. Our users see a single interface, but really it's several different applications that are speaking to several different backends. The business logic that used to reside in a single application now is residing across multiple applications. So the key takeaway is that this is a heterogeneous environment. And so we shouldn't constrain ourselves by language or runtime. We want to use the best possible tools to grow our services, to build them. So reusability means we want code that doesn't require us to predict the future. And if I'm going to extract my authorization into another service, or a part of my authorization into a separate service, I need to be able to do that without having to rewrite it. I don't want to have to rewrite everything. And loose coupling means that we're going to decouple the access decision from the access policy. So just restating that we can't use this outside of our Rails application. We also need whatever framework to be scalable. So there's when I was researching this, I was like, what are the available tools to be able to do something like this? And I didn't really find anything. I did find of this thing called XACML. I mean, raise your hand if you've heard of XACML. Yeah, so I see maybe 10 people have raised their hand. So XACML it's XML, and it stands for Extensible Access Control Markup Language. And it's a declarative policy language implemented in XML, and it defines a processing model that describes how to evaluate access requests according to rules defined in policies. So it actually, if you read the spec, it's I think hundreds of pages long, and it actually defines an entire architecture using XML to define authorization rules and sort of all these different services to implement authorization. And in fact, it uses a centralized authorization service, and it's pretty complex, I think. But I found this from the spec, and I thought this was actually really poignant. The XACML model supports and encourages the separation of the access decision from the point of use. When access decisions are baked into client applications, it is very difficult to update the decision criteria when the governing policy changes. When the client is decoupled from the access decision, authorization policies can be updated on the fly and affect all clients immediately. So this is what an XACML policy would look like. I got the indenting wrong, but I mean, you get the idea. It's pretty complex, but it gives us this advantage of being able to update and modify the rules without touching our application code. And so we should be able to use this in sort of in a heterogeneous environment, as long as we have some authorization library that we can use within our application. But I thought that this is way too much for what we needed, right? We don't have thousands and thousands of rules. Our application is actually fairly simple compared to the implementations I've seen for this. So I wanted to try something a little bit simpler, right? Thing is, I didn't really find anything simpler. So when we were discussing this authorization framework that I'm going to go over, we thought like, all right, let's come up with a very simple language that we can use, and as we build this out, as we test it, we can experiment with it, and if we need to bake more features into it, let's do that. But let's implement as few features as we need as possible, and so that's where we started. So just to recap, we talked a little bit about why we would choose SOA architecture, what SOA might be, and we set our goals to be scalability, flexibility, and loose coupling. And we talked about why we chose these 3 goals, like what are their benefits. So what did we come up with? And I guess I didn't really talk about like what this is, what this framework is, but I worked with a few guys in my company, and we said, all right, let's build this. It's not really a framework. It's more like let's define a language where we can define authorization policies, and it's agnostic to Rails, whatever it is, and let's try to create like a reference implementation and experiment with it, and then see if this is a rich enough language to be able to use and replace whatever we have today. So this is sort of like the v0.1 alpha of the language, right? There's not like an official spec that we have a very like early spec for this, and this is sort of like what we came up with. And I'll go through like each object in this JSON. So we have a resource. A resource could be defined within a namespace, and so it could also be like just the name of a class. So like if it's a Rails application, it could be like an active record model, an action or a set of actions. So a rule will apply to a set of actions, just like in CanCan, you sort of do the same thing. You have a set of conditions that define the evaluation context of a rule. So whether a rule applies or not. So in this case, this is like how we would say like the role of a user must equal admin. So if we're right, and then every rule will have an effect. So it'll be either allow or deny. So we have this language, but something is missing, and that's what's sort of bridging that gap, right? We have an application, now we have a set of rules, like what's connecting the two? And so, right, I wrote this really small gem, and it's called Ironhide. And we just have this practice of naming all of our gems at work after transformer characters. So Ironhide is sort of this bridge. We define a set of rules, and we have our application, and then we include Ironhide into our application, and Ironhide exposes the same API that CanCan would, and so it's sort of like a drop-in. And so like what is it? It's not a service. It doesn't provide an authorization service for us. It's actually just a library. So that's an important distinction, because where are the rules, right? If it's not a service, then it's going to have to call out and get the rules from somewhere. And that's actually pretty cool, because we can store the rules anywhere we want, right? It's just JSON. So JSON can really be stored anywhere. It can be stored like on disk. It can be stored in a document store, and having this like pluggability to different backend stores gives us scalability. So does it meet our goals, right? Usability, scalability, loose coupling. The authorization rules are not part of the application code. The language in which we define the rules is language agnostic, so it should be reusable across environments. And if we've decoupled the backing store from the authorization implementation, then it should be as scalable as we want it to be. So today, it's still a work in progress. It's still something that we're experimenting with, right? XACML is it's a very well-defined spec. I think it's like version 3.0 of the spec. It's sort of like an enterprise level design. This is like, we're experimenting with it. Could it scale to thousands and thousands of rules and to like many, many services? I don't know yet, right? It's not yet in production. But, and it's also something that, we need to standardize and name the policy language, right? There's no name for it. So I'd like to actually do a demo. So let's see if this works. Where is this? Can everyone see that? No. If I make the... Too small?
No, we can't see the bottom.
Oh, you can't. Oh, yeah. Would it be better if I made the background light and the foreground dark? No. Okay. All right. So this is this is a rule, right? This is I've written this just directly into a flat file on my disk. So there's some resource under this app namespace, a set of actions, an effect, and a set of conditions. And then I actually made a really simple, it's not an app, it's just I created a user class. It has a manager ID and an ID. And if you look at the rule, I'm saying that a user is allowed to read or manage another user. In this case, the resource is also a user. So we're always authorizing against the user. So the user is allowed to do something to another thing. And in this case, it's another user. As long as the user's ID is equal to the other thing's manager ID. So here we have a user with a manager. I'm going to run this and then jump directly into the console so I can start writing code. Okay, so I can let's see, user. Right, so this user has a manager ID now that's equal to the manager's ID. And then I didn't really go into depth into the Ironhide library, but I'm going to post a link to the source. I tried to write a pretty well-documented README, so it should be fairly self-explanatory. Basically, there's a configuration. Oh, crap. Okay, and then so it's it works. Yeah, it's actually kind of funny because I tried recording this, and it was probably easier doing it live. All right, let me try to jump back. So yeah, these are links to the source. So that's I tried getting a short link for the GitHub page, and there's actually a sample app with sort of what it was sort of like that, maybe with a few additional things. And then I also wrote like an adapter that would let you use like CouchDB as the backing store for the rules. CouchDB is pretty cool, so that was the first time I used it. Okay.